Hi guys, let's do this problem. Guys, I first read the question. A committee of 11 members is to be formed from 10 men and 6 women. Determine the number of ways in which it can be done to include at least 4 women. And so guys, we start this question. So guys, we are going to start with the inclusion of 4 women because we are talking of at least 4 women. So I will write 6 combination 4. This one represent for 4 women. Now times, guys, the remaining members are supposed now to be, because the committee is for 11, then you have 7 members here remaining. So I will write 10 combination 7. So this is the committee that consists of, this committee consists of 4 women and 7 men. And then we go to the next committee. This other committee, guys, contains 5 women. So we write 6 combination 5. Now times, this is now going to be 10 combination. Now for men, we are going to have 6 men. So we are going to calculate that. The next committee, guys, is going to have now 6 women. So we are going to write C combination 6 combination 6 times, for the men, we are going to have 10 combination 5, because for the men, we are going to have 5 men in this committee. So guys, we are now going to calculate the number of ways we can make each of these committees. That is, this is the first one, the second one, the third one, and then guys, we can add them together. So guys, we now do this problem where we have 6 combination 4 is 6 factorial all over 2 factorial, 4 factorial. This comes in because you say 6 minus 4 is 2. So that's what happens. Times, for this is going to be 10 factorial all over 7 factorial, 10 minus 3, 3 factorial. For this other committee, guys, where we have 5 women, we are going to have 6 factorial all over 5 factorial. 6 minus 5 is 1 factorial times 10 factorial all over 6 factorial. 10 minus 6 is 4 factorial. For this one, you're going to have 6 factorial all over 6 factorial, 0 factorial times 10 factorial for this all over 5 factorial. 10 minus 5 is yet again 5 factorial. So let's call this committee Roman 1. Then we have this committee Roman 2. And we have Roman 3. So guys, now we come and calculate Roman 1. For Roman 1, guys, this we are going to have, we are looking at 6 factorial over 2 factorial and 4 factorial. This, guys, is going to give us, we can write 6 times 5 all over. Now, because of 4 factorial, guys, we may not write 4 because the 4 factorial will cancel for 3 to 1 this side. So I can write now 2. Then times, this is going to be 10 multiplied by 9 all over, that is 9 times 8. Then I don't write 7 because 7 can be cancelled by the rest of the numbers here. So I will write now 3 times 2, like that. So this is now going to be, the first one is going to be 15 times, it's going to be, you divide by 3 there, by 2, you're going to have 4 there. So this is going to be 120. And so therefore, if you multiply that, guys, we are going to have 1800. Guys, now we go to the second, that is Roman 2. It's going to be 6. For 6, this is multiplied by, you can leave it like that because when you multiply by 5 and so on, this 5 factorial is going to cancel that. So now we multiply by 1. This is now going to give us 6 times, we have 10, that is now going to be times 9. We're looking at this times 9. Oh, this is what we are looking for, times 9, times 8, times 7, all over 4, times 3, times 2, times 1. For 6 is going to be cancelled because we have not written up to 1. And so therefore we do this. This is now going to give us, here we have 6 times, here we can cancel 3 by 3, we are left with 3 there. 4, we are left with 2 there. And then we have 2 here, then we get 5 there. So guys, we shall have 15 times 14. 15 times 14 gives us 210. So guys, this is now going to be equal to 6 times 210, which is 1260. Guys, we go now to the last one. That is Roman 3. We are going to have 6. That is all over 0 factorial. Then multiply by 10 times, this is times 9, times 8, times 7, times 6. So the others will be taken care by one of the 5 here. So I can divide this 5 and that. So by 5, 1, by 5, 2. So guys, we are left with that. This is now going to give us 6 factorial all over 0 factorial gives us 1. So this one we get 1 times, because guys, before we come here, this 5, we have 5 times 4 times 3 times 2. Guys, I had forgotten that. So we can also divide by 4, we get 2 there. By 3, you can get 2 there. And then the 2 can finish with these 2. So guys, you are remaining with 2 times 9 times 2 times 7. So guys, this gives us 252. And so therefore guys, our solution then for Roman 3 is going to be 252. Guys, now we can add all those committees. So we are going to have 1800 plus 1260 plus 252. And this one will give us now, our solution then is going to be 3312. So guys, this is our solution. And guys, thank you for listening to me. Bye bye.